Hey, it's Mr. Allred, and I want to talk about prime factorization. Prime factorization is writing a number as the product of prime numbers. So if you're familiar with prime numbers, these are numbers that don't have any factors besides 1 and themselves. So numbers like 2, 3, 5, 7 that you can't break down, and there's really large numbers that can't be broken down as well. But I've got some good examples and some bad examples here. So over here, for my first example, the prime factorization of 30 would look like 2 times 3 times 5, because you can't break 2, 3, or 5 down anymore. And if you multiply all those together, you get 30. Now on the other side, something that's bad, let's put a big X beside it so that we know it's bad. Let's see if I can just kind of glance over it here. 2 times 15 equals 30. Well, 2 times 15 does equal 30, but 15 can be broken down again, right? It's 3 times 5. So this is not the prime factorization of 30. The second row, 2 squared, which is 2 times 2, but 2 squared times 3 times 5 equals 60. Well, this is the way, if we have multiple factors, 2 squared, we would write it. Okay? We could write 2 times 2, or we could simplify that by writing 2 squared. But what we don't want to do is on the right hand side here write 4 times 3 times 5, because we could break 4 down. Now if it was like a bunch of 2's, you wouldn't want to write all those 2's, so you'll write 2 squared or how many ever. But over here on the right hand side, these are bad. Okay? Because they're not broken down enough. Okay, so let me show you how you can get to the prime factorization of a number, because it's something you're going to use. Okay, let's see if my pad, yes. So the example we're going to work with is 72. So I'm going to make a factor tree, which means I'm going to kind of break 72 apart. And there's several things that 72 can break apart into. So you need 2 things that multiply together to give you 72. And we don't all have to pick the same 2, but we have to pick 2 that work. What I'm going to do is 8 times 9. I think you could pick 6 times 12, and there's many others. But what we're going to do is we're going to follow this down, and we're going to break apart every number we come to until we can't break it apart anymore. So we may run out of room and have some problems, but we'll be okay. 8 can be broken into 2 and 4, and 4 can be broken into 2 and 2. So 2 can't be broken down anymore. 9 can be broken into 3 times 3, and 3 can't be broken down anymore. So what I'm going to do here to make sure we see it is I'm going to circle the end of all of these, which is a bunch of 2's and a couple of 3's. Okay? And everything above was just work that got me there. When I say a factor tree, we want to go down to the smallest root of the tree. Okay? It's an upside down tree. But when we write this out, we can say 72, the prime factorization is, we've got 3 2's, so that would be 2 cubed times, and there's 2 3's, 3 squared. So you could do the math and multiply all of those back together and get 72. Some numbers are going to be more familiar than others. For instance, over here, the next one we're going to do is 112. Let's make it wider just in case. 112 will break into, you can always pull out a calculator, but 4 and 28, I think, I'll work this out a little bit earlier. Yes, 4 and 28. 4 will break into 2 and 2, so we're done with that part. But 28 is 4 and 7, 4 times 7. 7 is prime. You can't find anything to multiply together to give you 7 except 1 is 7. But again, 4 is 2 and 2. So if I capture all these endpoints, 2, 2, 2, 2, and 7, I can write the prime factorization of 112 as 2 to the 4th times 7. And it's not hard. You just have to take care. You want to be careful because sometimes your brain, when you're just sitting there trying to figure it out in your head and you're kind of guessing and checking, doesn't always give you the answer you really should be getting. So just be careful.